Hello everyone and welcome back. We are finishing up chapter 6. We're going to break up 6.5 into two parts because weather is a long section. So this first section will be on atmosphere and air pressure. And these are your guided notes for 6.5a. Okay, so what is the atmosphere and what is its importance? The atmosphere is a thin layer of gases that surround the Earth. The importance is that it contains oxygen, carbon dioxide, and water necessary for life. Without oxygen, we don't breathe. Without carbon dioxide, plants don't exist. It acts like insulation, keeping Earth at a livable temperature. If it gets too thick, we could run into the greenhouse effect and it could heat up. If it gets too thin, we won't have enough heat to keep us alive. It also protects organisms from the sun's harmful rays. Remember, the sun is giving off radiation, and this can cause things that are very harmful to us, and we can still get harmed by things like too much exposure through sunburns, cataracts, those sorts of things, so we still have to be careful. And it also causes meteors to burn up before hitting Earth. It acts as kind of like a shield from some of the smaller meteors. It's a very thin atmosphere. If the solid part of the Earth were the size of a peach, the fuzz of the peach would represent the atmosphere. So it's just a little thin layer around the outside. It's really not very thick. So what is it made up of? Well, mostly nitrogen. 78% of our atmosphere is nitrogen. 21% is oxygen. Now the rest is a small amount of other gases like water vapor, argon, carbon dioxide, ozone, methane. And there's also a little bit of solid that's floating around up there, like pollen, dust, or salt. And depending upon the temperature situation and the weather, it could contain water droplets as well. Some days that are more humid, you might have more water droplets, and some days that are very dry, you would have fewer. So how is temperature distributed in the atmosphere? The atmosphere is divided into layers based on differences in temperature. There is the troposphere, the stratosphere, the mesosphere, and the thermosphere. How does altitude affect air pressure? Altitude is the distance above sea level. So imagine where the level of the oceans we're at. That should be about the level at sea level is at, so that'd be about 0, and then we count up from there. As you go up, air becomes thinner as altitude increases. Now in the little picture you can see that the air starts to spread out and get thinner and thinner. If you climb a mountain, you might start feeling a little bit short of breath. If you climb Mount Everest, you actually need to bring extra oxygen along with you just to survive. So what is air pressure? Well, it's the force that a column of air exerts on the air or surface below it. So you imagine an area, a column of air extending all the way up to the top of the atmosphere above your head. It is pushing down on you with a certain amount of force. It is measured using a barometer. Air pressure moves from areas of high pressure to low pressure. So areas where there are a lot of atoms and smushing together and hitting each other hard to areas where there are fewer. So how does temperature affect air pressure? Well, cold air molecules are closer together because they have less energy, making them more dense, and they will sink. Think about all the atoms as bouncing off each other. When they hit each other a little bit slower, they don't have as much energy, so they don't hit as hard, they don't bounce off each other very far, and they tend to stay closer together. Now, once you add energy, those molecules start bouncing off each other with a lot more speed, and they spread out. So warm air molecules are farther apart because they have more energy, making them less dense. They rise. That causes warm air to go up and cold air to sink. So that is where we are going to end these guided notes. We will move on to 6.5b in the next video.